Hi everybody, just some quick notes today. A lot of this stuff we've really done just about every day lately, factoring, solving, factoring and solving anything, absolutely anything, square roots, imaginaries, quadratic formula, all that kind of stuff. So I'm on page 146, and I just want to show you this real quick because it's a little bit to take you kind of to challenge yourself maybe to think of everything that looks like the difference of two squares. So what I mean by that is it's obviously called the difference of two squares for a reason. But if you think about something like this, x squared plus 5, normally we would say, well, that's not the difference of two squares because first of all, it's not the difference. And of course, it's not two perfect squares. But you know the pattern of it, it's always going to be x plus the square root of that number and x minus the square root of that number. And you can take the square root of anything, absolutely anything. Negatives, fractions, perfect squares, non-perfect squares. And so basically this little part is sort of saying, hey, why don't you just think of everything as a perfect square, that anything that you can take the square root of, which is what they're saying here. So because you know that this is really I radical 5, now we can sort of think of everything this way instead of being so always restricting. Like up until now, it's always like, oh, you can't factor that, there's a plus sign, or oh, that's not a perfect square. But really, you've always done it. We just have only sort of forced it on difference and perfect squares. So that being said, the directions say to write this as a product of complex factors, and what they mean by that is don't really solve it all the way out. We're not finding the zeros. We just want to leave it in factored form. And so for like this one, x squared, I'm looking at a, x squared minus 8. So we know it would be x minus its perfect square and x plus its perfect square. It's got a minus in it, so it's not going to have any imaginaries. So when there's a minus, that means no imaginaries because you're going to have, you're taking the square root of something positive. So it's 2 radical 2. If there is a plus sign in between, now it's going to have imaginaries. And that's the main difference. Plus sign means you get imaginaries. Minus sign means you don't get imaginaries. So this is going to be x minus I radical 11 and x plus I radical 11. And just to try it again, for this x squared plus 9, again, just to leave it as factors, this would be x minus 3i and x plus 3i. And then, of course, where there's a minus sign, like in the 4 here, we would not get imaginaries. So it's not super essential. Something obviously you could live without, but it's just another way to look at it. In case you've always looked at it that way, now I guess we're saying formally, hey, it's really true. For the factoring on the next page, now we really want to find it. You writing this as a product of complex factors is not something that I'm ever going to ask you to do. I'm not going to ask you to do this. I'm just going to ask you to find the zeros. So that's really what we're working on today, just finding the zeros. Really given anything that factors, doesn't factor, imaginaries, fractions, doesn't matter. So anything goes stay with our factoring. So, of course, all even powers are perfect squares. So here we would get x squared minus 4 and x squared plus 4. Of course, set this equal to 0 so we can find the answers. And now, because the idea is that if you could do the linear factors like we just did, that you could just go ahead and solve these now. If you're already thinking that way, there's no reason to write down each equation. So we would get x equals plus or minus 2 and x equals plus or minus 2i. And those would be our 4 answers. Just like I've been telling you, your book, I'm going to skip B. Your book really does, when you see 4 things, it really, really does factor by grouping. No rearranging. Don't even really need to second guess it. It's going to be that way all the time. So they have an x squared in common. Don't forget the 1, please. We are dividing. X squared divided by x squared. And then the next two have a 4 in common. Again, leaves you with the 2x minus 1. Bring out your common factor. And we're left with x squared plus 4, of course, still equals 0. And so we get x equals 1/2 and x equals, we just had this, plus or minus 2i. For part D, put it over here. When you start with the power of 4, you can't use the quadratic formula on that, please. It's not a quadratic, plus it's factorable. So x squared and x squared multiply to get 5, add to get 6, 5 and 1, minus and minus. And so here we would get x equals, so they're both minus, so no imaginaries, x equals plus or minus 1 and plus or minus radical 5. Just to go through quadratic formula. On the ones that are not factorable. So part A here. 11, multiply to get 11. You're not going to add up to get 3. So we would have the quadratic formula, which I'll put here if you need to see it, the opposite of B, plus or minus the square root of B squared minus 4AC all over 2A. If you would rather use completing the square, please do so. I'm going to use the quadratic formula. I think it's a little bit faster, especially when we have lots of odd numbers. As you can see here, just a little bit easier to do this with these odd numbers. So negative 3 plus or minus. When you're doing the quadratic formula, don't be afraid to write down the parts. Sometimes the signs are confusing. It doesn't mean anything other than the signs are confusing. It's not that big of a deal. So 9, and then the minus 4, A is 1 and B is 11. And sometimes if you just have that written down, even just to look at, it makes it a little bit easier. It's easy to make a sign mistake on the calculator. So we have 9 minus 44. So we have negative 3 plus or minus the square root of negative 35 over 2. So we have negative 3 plus or minus I radical 35 over 2. Oh, sorry, I can't really read that. Now for part B. This is not a quadratic. Please look for the greatest common factor. A lot of times your greatest common factor is also going to get you some answers. So failing to take it out would mean you most likely don't have all the answers that you should have. So they do all have a 3x squared in common. And now we have x squared minus 2x plus 7. So 3x squared, there's your two answers right here, right? X equals 0. It's a double root. Two answers, bounces, so it's important. And then for our quadratic formula part, opposite of B, plus or minus the square root, B squared minus 4 times A times C, all over 2A. So we get 2 plus or minus, I'm going to write this out a little bit. This is 4 minus 28, so we have negative 24. That needs to be simplified, of course. If you're not so good at simplifying the perfect squares, you can always make a factor tree. It doesn't matter where you start, as long as you start with something that's true, like 2 times 12. Don't start with like 2 times 5, because that's not true. And then it also doesn't matter where you go from there, right? So we're just trying to break this down. We have two 2's, and this 3 and 2 do not have a match, so they have to stay under the radical. So that's the 2 from right here. We're bringing out this 2. Also the I, and then the radical 6, and then there's a 2 in the denominator. And of course, all 3 of these get reduced. Now remember, this is a 1 that we need. The other ones are optional. And if you're not sure if you should write them, then write them. So we get 1 plus or minus I radical 6, and then another answer was 0. That is all 4 answers, because 0 was a double root. And then finally, I just want to show you one more. Ignore the long division. I see you looking at it. We're not doing that. But take a look at this last. We're not going to do B or C. Just to try these A. So here, they give you that 2I is a 0. It's a factorable problem, right? 100, 4 times 25. Let's say maybe you didn't understand that that was a factorable problem. Maybe you didn't notice it or it didn't occur to you. The fact that 2I is a 0, as you know from yesterday, that means that negative 2I is also a 0. And so now it's understood. This is what we started with, the first 3 problems when we factored these out. Now that you kind of understand what it looks like with the difference of 2 squares from when you start with the polynomial and end with the factors. The idea is if we started with the factors, you could go back to the polynomial. When it's I, you know you're going to have a plus sign in the middle, and you're going to have x squared, of course, and then you would multiply that together, and so this would really just be x squared plus 4. So essentially, I know this one is factorable, but it's really just providing you a hint, which you could either use or not use. Again, I'm just trying to connect it to the very, very beginning to show you this. So for then this one, It's not supposed to be confusing or different. It's just another way of looking at the problem. I didn't want you to think it was completely different. It says find all of the zeros if you're given one complex zero. And this is extra easy because we're not going to do the ones that involve the long division. So that's why it seems kind of silly, but we are going to do the ones that you can do without the long division. So that's supposed to help you factor it. Oh, I know that x squared plus 4 is a factor. So the only 100 divided by 4 means that 25 has to also be a factor. That's supposed to be a 25, by the way. So 25. And so it must be x squared minus 25. And then, of course, we could go and find all the zeros. We already know these. This is plus or minus 2i, right? Because that's where we came from. And then this is x is plus or minus 5. So not, like I said before, it's not a whole lot. And if anything, there's not really anything new. It's just maybe a different way of looking at the difference of two squares. So in your assignment, it's right here on page 148, 3 through 9. I guess what I'm going to say is pretty much ignore the directions. Just find the zeros. Find the zeros. Find the zeros. All right, so that's all you have to do is find the zeros. Most of these will be factorable. You'll see that I believe there's at least one or two maybe that are not factorable. So quadratic formula or completing the square. Thanks. See you tomorrow.